All right, we're going to go over our lesson from Monday talking about eclipses. Now, this is the lesson from 10/12. So that's Monday, October 12th. And we talked about eclipses, and we have a notebook actually available for you to look at. And I'd like you to open that up starting with our Google Classroom. So, again, go to your Google Classroom, whatever period that's science for you. And in that, you're going to see that lesson available under week 7 right here. So week 7, we're looking at the Eclipse notebook for Jensen, students in Jensen, and that's the one from Monday, the Eclipse notebook. Now on this, it's not going to be graded, but it's going to be just notes you can use on the quiz Friday so that we can look at this thing together. So here we go. Day 1, the main learning target we're going for is this. Can you explain why we have eclipses? And could you model maybe in 2 different kinds of eclipses that we see from Earth? So can you explain it and could you model it, how we get these eclipses? Those are the 2 things we're going to try to do by the end of this lesson is can you explain what an eclipse is and can you actually model it? Well, here we are first of all. Let's just write in the word eclipse. That's the main thing that we're looking at. And what is an eclipse? Well, it's a total or partial obscuring or blocking of a planet or a star or a moon by any other object in space. So anytime there's an object in space that blocks or obscures a planet or a moon or anything like that, a star possibly, that's called an eclipse. The passing of an object into the shadow also of a planet, star, or moon is another example of an eclipse. So anytime there's an object in space that's blocking another object, we call it being eclipsed. Eclipsed. What about this one here? Well, the first one we're going to look at, we're going to use the word Sol, because Sol is the name of our star. Right here in the solar system, we have Sol, our star, right in the center. If you ever wondered, I didn't know our star had a name. I thought it was just called Sun. Well, yep, Sol is what we use as a formal name for it. Solar, talking about a solar system, or we're talking about solar panels. We're talking about the sun's energy. We're talking about the sun involved with it. This one, we're talking about a solar eclipse. It's involving the sun. It occurs when the moon moves in between the sun and the earth. So when the moon becomes like the cream filling inside of an Oreo, the sun is one crust of an Oreo, the earth is the other crust, and the cream filling is like the moon. That's when we get that solar eclipse. And what's happening is the sun, Sol, gets totally or partially blocked. Sometimes it's partially blocked, but solely blocked is the really cool one. So a solar eclipse happens when the sun is getting blocked by the moon. And you can see it right here in this diagram. The moon then casts a shadow on the earth because of that. Now, it's not a large shadow. And you can see there's 2 different colorings of shadows. In fact, there's a dark coloring shadow called the umbra, and there's a lighter shadow called the penumbra. These are going to come up a little bit later in this, but just know that the really dark shadow called the umbra is pretty small, actually. It's not as big as you would think, and that's where that total eclipse, where it's completely covering the sun, happens. Well, which moon does it occur as far as the moon phases? This occurs during a new moon phase. The new moon phase is when this occurs, and that is when we are in alignment to where the moon is between the earth and the sun. Now you're thinking, does this happen every single month during a new moon phase? No, it doesn't. In fact, it has to be at the right angle and the right part of the revolution around the sun. So let me explain this a little bit better. As the earth is going around the sun, the moon is going around the earth. The moon doesn't go perfectly around the earth equal to the sun. Actually, it's got a little bit of a tilt to its orbit. So as the moon goes around the earth, it's just a little bit above or a little bit below what would be the perfect spot to cast a shadow. But every so often, as the earth goes around the sun, there is a point when the moon comes down where it's perfectly in alignment so that it can cast a shadow on the earth while the sun is shining. And that does happen, and it can only happen if we're in a new moon phase, and it has to be just the right angle of the earth going around the sun and the moon going around the earth for that to happen. So it doesn't happen every month. It doesn't even happen every other month. It takes a while for that to happen. And so we don't have solar eclipses very often. In fact, if I was to open up a quick document to show you, you could see that right here, solar eclipses have not happened very often. We did have one across America in 2017, and we are suspected to have our next one in 2024 that's going to go across America. We have one in 2020, 45 and 99 and 71 and 52, all sorts of years planned, but very few and far between. And that line is pretty small. This is where you would see the total eclipse. You'd see the moon fully covering completely the sun, but they don't happen very often. So when we think about this, we think, oh, I thought that moon phases happen because the Earth's casting a shadow. Not at all. The Earth doesn't have any shadows on the moon as far as moon phases. Once in a while during an eclipse, it does. Or the moon doesn't cast a shadow on the Earth. Once in a while, when the alignment's perfect, it does happen, though. But it has to be in that new moon phase for it to work in a solar eclipse. When the moon tucks behind the Earth, we have what's called a lunar eclipse. Luna being the word for moon, a lunar eclipse is when the moon is eclipsed by the Earth. So now the Earth is blocking the sun from the moon in a lunar eclipse. Now, it occurs when the Earth passes between the sun and the moon? No, it does not. Not at all. Behind sun and the moon. Yep. Is that right? No, just messing with you. Between the sun and the moon. Yep. When the Earth passes between the sun and the moon, that's when it happens. That's when it happens. When the Earth passes between the sun and the moon. That's when it happens. That's when it happens. This can become confusing. The moon between the Earth and sun is a solar eclipse. The Earth between the moon and the sun is a lunar eclipse. The Earth casts a shadow now on the moon. The moon will turn a really cool red color when completely in the Earth's shadow. And you're thinking, wait a second, Mr. Jensen, look at the size of this shadow behind the Earth. Why in the world wouldn't the moon have a casted shadow every single month? Remember, this is not to scale. This moon should be way out here because we can fit 30 Earths between the Earth and the moon. So think of this Earth counted 30 times to your right. It's going to be way on a whole nother monitor screen that you're looking at. No, to make this work so you could see it, we had to bring the moon in really close, shrink down our sun, bring it close so you could see this model. But by all means, the shadow of the Earth is actually quite small. It's just about the width of the moon, just a little bit larger. Now, the umbra shadow is that dark, straight dark shadow that the Earth casts. And then there's kind of a less of a shadow called the penumbra that happens as well, where you're a little bit affected by it. Here's a picture of it turning red. Slowly, you're going to see a full moon change all in one night, not over months, but all in one night. And you're going to see this creepy black shadow creep over the moon. And then it's going to fully cover the moon, except for it's not going to be black. It's going to turn red. They call it a blood moon because it turns blood red. And then after about an hour and 20 minutes, you're going to see it, change. Again, it's crazy when you watch this live. It takes a little bit more time. A solar eclipse, you're going to see it for 10 minutes maybe. But a lunar eclipse will last a lot longer, so you have more of a chance to see it. And of course, this happens during a full moon phase. That's when we see a lunar eclipse, is during that full moon phase. Now, a couple of things. Let's just answer these questions and make sure we're following okay. Discuss differences between a lunar eclipse and a solar eclipse. Okay, Mr. Jensen, what's question one? When do they happen? Daytime or nighttime? Well, a solar eclipse is blocking the sun. So for us, we're going to be facing the sun. A solar eclipse happens in the daytime when we're facing the sun. A lunar eclipse happens in the nighttime when we're facing away from the sun on Earth. That's when we would see a full moon and we'd see a lunar eclipse. So solar eclipse is daytime, a lunar eclipse is nighttime. Question number two, what moon phase happens during each eclipse? During a solar eclipse, the moon phase, new moon happens. During a lunar eclipse, the moon phase, full moon happens. Question number 3. What is the position of the sun, earth, and moon during each eclipse? During a solar eclipse, the sun with the moon in between the earth happens. During a lunar eclipse, the sun with the earth in between the moon and sun happens. I think we're feeling a little bit good. Let's watch a short video and see if this makes sense to you a little bit better after this video.
A solar eclipse happens when the moon's shadow falls somewhere on the surface of Earth, and a lunar eclipse is the opposite, when the Earth's shadow falls on the moon. The two sections of the shadow, the dark umbra and the partially shaded penumbra, their placement determines which type of eclipse we can see from Earth. But not all eclipses are made equal. The most spectacular, the one for your bucket list, is a total eclipse of the sun. A total solar eclipse begins as a partial eclipse. You'll notice trees projecting the crescent sun and shadows becoming sharper than normal. The landscape darkens to a bluish gray, and you'll start to feel the temperature drop. From the west, the moon's shadow rushes towards you like a silent storm. Look up, and you'll see the last sliver of the sun sparkling like a diamond ring before it's broken into a string of beads by the moon's rough terrain. Now you can see the pearly glow of the sun's corona and the pink and red light from the hydrogen gas of the chromosphere. Together, these make up the sun's outer atmosphere, and a total solar eclipse is the only occasion you have to lay eyes on it. This is totality, and if you get a chance to see it, you should. The moon orbits Earth every 29 and a half days, but we don't get eclipses every month. That's because the moon's orbit isn't in line with Earth's orbit. It's tilted about 5 degrees. That doesn't seem like much, but keep in mind that the scale of the model we're showing to you is way off. If the Earth and moon are this size, the distance between them should be around 10 feet. At this distance, 5 degrees is enough to keep the moon's shadow off of Earth and the Earth's shadow off the moon most months. So why do we ever get eclipses? Because there are 2 points where the moon's orbit crosses the sun's plane, called nodes. And as the Earth moves along its annual orbit, those points line up with the sun about twice a year. As the moon passes between the sun and Earth at that time, we get a solar eclipse. And when it's behind Earth at that time, we get a lunar eclipse. There are a ton of orbital quirks that make predicting eclipses really complicated, but in general, we'll have a few solar and a few lunar eclipses of some sort every year. But you're more likely to see a total lunar eclipse in your lifetime than a total solar one. The totality of a lunar eclipse can last well over an hour, and it's viewable for anyone on the night side of Earth. The moon often turns red during a total lunar eclipse because our planet's atmosphere scatters the bluer wavelengths of light while the longer, redder wavelengths pass through. Or to put it another way, a total lunar eclipse projects all of the world's sunsets and sunrises onto the moon. Total solar eclipses seem much more rare because totality lasts just a few minutes, and although Earth gets a total solar eclipse every 18 months on average, each one is only viewable by less than 0.5% of Earth's surface. Eclipse chasers travel all over the world to put themselves in the path of that shadow. In a total solar eclipse, the moon precisely covers the sun from the vantage point of some place on Earth. This is possible because, by coincidence, the sun and the moon appear to be about the same size in our sky. While the sun is 400 times bigger than the moon, it's also about 400 times farther away. But this alignment isn't constant. The moon has an elliptical orbit. Its size varies about 12% throughout the month. When it's closer to us, we can get total solar eclipses, but less than 30% of solar eclipses are total. More often, we get partial eclipses, where the alignment is a bit off, or annular eclipses, where the moon is too far away to fully block the sun, leaving a ring of sunlight around the moon. In the far future, Earth will only get annular and partial solar eclipses because our moon is moving further away. We know that because Buzz Aldrin and Neil Armstrong left mirrors on the moon in 1969. Astronomers bounced lasers off those mirrors to measure the moon's distance, and that's how they found out that the moon is moving away from Earth by more than 3 centimeters per year. So in a billion years or so, whatever creatures live here will witness Earth's very last total solar eclipse.
We can see on the radio on the screen A fantastic total solar eclipse taken from the pictures above the clouds. Fabuleux enfin! Et alors, c'est probablement sensationnel! Chef, verstehen wir mir was sieht man in so einem Moment, Herr Philemon? Ja, super. This is just fantastic.
A lot of early civilizations feared eclipses. They were seen as an attack on the sun or moon by the forces of darkness. But now that we understand our place in space, eclipses are an occasion for awe and for gratitude. All over the galaxy, rocks are casting shadows on other rocks, but only here, as far as we know, is there someone to notice them.
All right, so hopefully that video gives you a little bit more insight into why we have eclipses. It's pretty cool to see some of those live videos. And I definitely will say, for me, in 2017, when I saw it live, it was over the top cool. Something that you cannot explain to somebody unless you're there to experience it. But it's literally out of this world, the craziest thing you could ever imagine. Seeing it firsthand is something I would definitely recommend. If you ever get a chance in 2024 to make it across the United States to this thing that we're going to have, this solar eclipse, you must be there, because it literally is the coolest thing you'll ever see. And I promise you that. I could put a promise on that, a bet on that. Okay. With that, again, what is this? Now, this is called a total solar eclipse. That's when the sun is totally beaten out. Totally, 100%. If it's not totally, then it's a partial solar eclipse. That's where most of it, but not all of it, is covered. And so in 2017, here in Cheney and Spokane, everyone said, we saw a solar eclipse. It was a full eclipse. No, it wasn't the total. It was a partial here. You had to go down to actually areas inside of Oregon and Idaho to see it totally. But there was a partial eclipse here. A solar eclipse, once again, is when you're blocking the sun with the moon, and so you get a shadow on the earth. Not super huge. The total shadow is that dark part right there. That is where you have the full. Around it, you have a partial. So it's the umbra versus the penumbra. And they usually track where it shows you. So on August 21st, 2017, that blue line represented where you'd see the total eclipse, or it completely covered the moon fully, as you can see in this GIF up here. That was where you'd have to travel to see that full solar eclipse like that there. An annular solar eclipse happens, and it's where the moon is just a little bit further away from Earth, because it does tend to be either closer or further just slightly. And so in that case, it's not perfectly lined up with the sun to where it's the same exact size, but it is lined up to where it does cover the sun, and that's called an annular eclipse. Now, a total lunar eclipse is when you get that blood moon. That's the cool thing. It has to be a total lunar eclipse in order for that to happen. And when that does happen, you get that blood red moon where it's completely covered. If it's partially covered, it just shows up as a black shadow. That's really it. And the moon still stays that same moon color that we're used to on a full moon. But when it's totally covered, that's when you get the red. Mr. and Wagner and I, the last total lunar eclipse, went out past Davenport. There's some great areas out there that you could see the Milky Way galaxy and stars just really appear out there. You're way out away from the light of the town, cities, anything around you. And in that dark area, we saw that lunar eclipse, and it was beautiful. And here's a picture of us with it in the background. And of course, we put on one of the Chinese satellites that had recently landed on the moon at that time, just as a joke. But here we are with that lunar eclipse. So cool to watch. It takes a long time to sit there and watch it go full, but it's really worth it. And I encourage you to do that. So lastly, what do we call that dark shadow? I call it the umbra. Umbra. Where's the sun? Because that's your reaction is umbra. Where'd the sun go? It's gone. And there's just this heavenly glowing orb out in the sky that you see. That is the umbra shadow versus the penumbra shadow, which is just still dark, but not all the way dark. The penumbra is the less dark shadow that happens. And so that's usually when we're not fully in the total eclipse, but we're in the partial eclipse. I hope this lesson helps you a little bit more. This, of course, is your notes that you can use on the quiz Friday. So please feel free to use that. Otherwise, have a great day, and we'll see you back in class.